All right, let's do number 4. All right, a 30-gram arrow. Let's write it down. Mass 30 grams, convert 0.030 kilograms, is shot by William Tell through an 8-centimeter thick apple. So we've got a distance, we know, of 8 centimeters, which if we're working in meters, usually, let's take that to divide by 8.08 meters. And if the arrow enters the apple at 30 meters per second, but emerges at 25 in the same direction, what force has the apple resisted the arrow? Now, remember, okay, so here's my arrow. It's going this way, and, you know, here's my apple here, you know, whatever. That's pretty good. So it goes through the apple and comes out the other end, and it is lost 5 meters per second. So the initial velocity was 30 meters per second. The final velocity was 25 meters per second. Okay. Now, if we want to figure out the acceleration, this is one we would probably have to figure out. What do we got? Well, we've got initial velocity, final velocity. We've got, we were trying to find acceleration. That's what we're trying to find. And we've got distance. And so we've got to look for an example that has all of that in it. And here's an equation right here. Okay, here's an equation listed over here. If we have velocity final squared equals initial velocity squared plus 2AD, change in D, you know, whatever. Okay. Well, do we have initial final velocity? We sure do. We have all of those velocities there. If we want to solve for A, now I don't normally do it the way they do it, so I'm just going to plug it in the way that I would normally do it. So I would do it 25 squared, 25 meters per second, quantity squared, and equals 30 meters per second squared. Let's get some parentheses in here. Plus 2 times A, we don't know. D is 0.080. Now, I would do that math, and I would multiply all that out, and multiply that out, get all those numbers together, solve for A. I think that most of you guys can do that part of the algebra. If we calculate all this, it's going to end up with A being negative 1720 meters per second squared. So I would multiply this out, subtract out this, divide by 2 times 0.080, and end up with negative 1720 meters per second squared. That's the acceleration or the deceleration of this arrow as it goes through the apple. Now, the question is, what is the force? So force equals mass times acceleration, and the mass was 0.030 kilograms times the acceleration, negative 1720. So what do we get for force? Well, that comes out to be negative 51.6 newtons. Can't write very well. Okay? All right, now we get to my favorite one. Example number 5. Rose is sledding down an ice-covered hill inclined at an angle of 15 degrees with the horizontal. if Rose and the sled have a combined mass of 54 kilograms, what is the force pulling them down the hill? All right, so let's take a look. First of all, this is vitally important that you understand a couple things. Whenever you have an object on an inclined plane, so here we've got this sled, whatever. Okay, looks more like a dog. We've got this object on the inclined plane, and the weight of the object, whatever this is, weight is always straight down. And in this case, I would probably call it, the book calls it, I would call it the weight, force of weight. But of course that is mass times gravity. So that's what that one's going to be. There's also a force called a normal force. And the normal force is always perpendicular to the plane that you're standing on. So in this case, we've got that inclined plane. The normal force would be perpendicular to this. So we get a 90-degree angle right there. So my normal force is this force right here. That is the force that is equal and opposite to you. If you're standing on that plane, you're applying a force to the plane. Well, the plane must apply a force to you according to Newton's law, equal and opposite. That's Newton's third law. And so this plane has to apply that force to you. So that's what that is. And we'll get into that, what equal and opposite stuff a little bit more in the next chapter. But that's what that force is known. And it's always at 90 degrees to the plane there, okay? So this is my normal force. And of course we know we've got some kind of an angle here. That didn't look very good. Okay, we got an angle there and so on. So the question is, where is the question? What is the force pulling her down? Well, there's a force here, force which we'll say is down the plane. Well, you know what? Really, this force right here, let's go with a different color. This force right here is this, we could rewrite it to be that force right there. So we can kind of figure all that. Now, one of the key things is whenever we work with vectors, they have to all be the same. So they're all force terms here. So here's my force down the plane. Here's my normal force. Here's my weight down the plane. Now, we could go through and we could do some geometry on this stuff, and I could show you how this is true, but just, you can just kind of believe me, or we can go through and work it out if you really want. But this angle here is always the same as that angle there. These are similar triangles. And so those angles are always going to be the same when we set it up just like this. So we've got all this. So really what we've got is quite a bit of stuff now. And let me rewrite this because I've got it's so scribbly here. So let's redo this. So here's my big inclined plane. Here's my, okay, let's go with a different color here. Here's my weight down. And that is going to be mass times gravity, and we said that she was 54 kilograms, so times 10. And so this is going to be 540. And then the normal force is right here. There's my normal. We don't know what that one is right now. And then here's my force down the plane. We don't know what that one is right now. But we do know this angle, and according to the problem, this angle is 15 degrees, same as this angle, 15 degrees. So now, it looked confusing at first, but right now it's really just a simple trigonometry problem. If we want to figure this out right here, we're simply going to use sine. Here's my angle, and the opposite side here. So we want to say sine of 15 degrees equals my force down the plane over my hypotenuse, which in this case is my weight of 540 newtons. And sine of 15, I don't know what that is, but if you take that on the calculator and punch it out, and I don't have a calculator right here in front of me, but sine of 15 times 540 is going to get you 140 newtons. So that's the force that goes down the plane. So don't make these really difficult. You're just going to draw, you're going to redraw the triangle,